All right, here we are again. So let's try another joke of the day. Have you ever tried to eat a clock? It's very time consuming. Okay, I was addicted to the hokey pokey, but I turned myself around. These are good. All right, a couple more. Why can't your nose be 12 inches long? Because then it'd be a foot. Ha ha. And the last one. Why did Star Wars, in honor of the new episode coming out here pretty soon, why did Star Wars episodes 4, 5, and 6 come before 1, 2, and 3? Because in charge of scheduling Yoda was. All right, so enough of that. Let's take a look now at factoring trinomials again. So we're looking at section 6.3. We've already done 6.2 where we're looking at factoring trinomials where the leading coefficient is a 1. But now in section 6.3, we're going to look at factoring trinomials when the leading coefficient is not a 1 and how that changes things. Remember, factoring trinomials reverses FOIL. So you've got to keep that in mind as you're going through this. Also, when the leading coefficient is not a 1, like I said before, you always check first to see if a common monomial can be divided out or factored out before you do anything else. Before you move to that double parentheses, you check and see, is there something common to every single term that I can divide out of every single term? Pull that out first and then try for a double parentheses after that. Now, once you've exhausted all that, there are 4 methods that you can use. There's actually 5 methods that you can use to factor your trinomials when the leading coefficient's not a 1, but these are the 4 that I prefer the most. Your first method is the old guess and check. Back in my day, guess and check is all that you had. And basically what happens with guess and check is you just keep guessing and you play with number combinations until you get the combinations right within the double parentheses so that when you check it by FOIL, you have what you started with. Guess and check sometimes can be a little long, it can be a little tedious, it can be a little old, but what happens with guess and check is with the practice you get very, very good at number sense. But there is a lot of guesswork to it. So the next methods, the next 3 methods eliminate a lot of that guesswork. Now factoring by grouping, what it does is it creates a common binomial factor and then you can divide out that common binomial factor. If you look back in your notes at section 6.1 part 3, we looked at a situation like that. If you recall, we had something that, say for instance, we had an s squared and in a parentheses an r plus s, and then we had a 2 and another r plus s. That should look somewhat familiar. And remember we said within that, it's very weird looking, but we had 2 terms, one being here and one being back here. And we said that within those 2 terms, we had a common binomial. This r plus s was common to both of them. So we divided that common r plus s out, and then we wrote down in a parentheses what was left when we did the division. We were left with an s squared here, we were left with a 2 here, and then we said this r plus s, as it's written, it looks like the s is only going to be multiplied through the parentheses, but the entire r plus s would be multiplied through the parentheses. So we need to put a parentheses around it. So therefore, that's how that common binomial got factored out. And what factoring by grouping does is it tries to set this up so that when you see that common binomial, you can factor the common binomial out and create your factored form. That's how factoring by grouping works. Your box method is based on this factoring by grouping. What the box method does though is it sets it up in a different format and it puts it in a box. It takes 4 terms that are created by your factoring by grouping and it puts those 4 terms within a box. And then you factor across the rows and you factor up the columns, and on the outside you put those factors that have been divided out. And so the answers are on the outside of the box and that's what creates your answer in your factored format. And then finally the last method is your slide, divide, and reduce. And the name tells you what to do. That is the nice thing about slide, divide, and reduce, is you don't have to necessarily remember a whole bunch of steps because the name tells you what those steps are. Now, you do not have to know all 4 of these methods. I'm going to show you all 4 of them and all the examples so that you can decide which method that you like and you can go with that method. But you are not required to know all 4 of these. You just pick the one that you like. But regardless of the method that you use, you always check your method by FOIL. If you can take your answer and FOIL it and get back to what you started with, then you know that you did it right. So let's try this out and see how this works. And I've got several examples so that we've got lots and lots of practice with this. All right, so in our first example, and in all of these, we are going to factor each. And our first example says 6c squared plus a 7c plus a 2. And like I said, what you do first is you always look to see is there something common that I can divide out before I do anything else. So with the 6, the 7, and the 2, no common numbers I can divide out. These have c's, this doesn't, I can't divide any c's out. So that tells me I'm headed for that double parentheses. Now if you are a guess and check kind of person, what you're going to do is you're simply going to say, well, I know that this tells me my signs will be the same. This tells me they're both pluses. I can split the 2 up easily into the back slots as a 2 and a 1. But this 6c squared, I'm not totally sure how it's going to split up. It might be a 6 and a 1. It might be a 2 and a 3. So you just have to take a guess. You have to put it in there. You have to FOIL it out and see what happens. If I try the 6c and the 1c, maybe it'll work. Outside here, I get a 6c. Inside here, I get a 2c. And remember, I've told you before that it's not necessary to check the entire FOIL. It's really just the outsides and insides to create the middle term. Because here, c times 6c better be 6c squared. That's how you split it up. 2 times 1 better be a 2. That's how you split it up. It's outsides and insides that you're worried about. These combine to be an 8c. So I know that that's not right. But before I toss out the combination of a 6 and a 1, maybe I should switch them up before I pick the 2 and the 3, because I have done a situation where I had several of these options and I tossed it out too fast before switching up. I exhausted everything and it was right in front of my face. So switch it up first, and if that doesn't work, then toss it out and see what happens. So I made the 6c over here and I made the 1c over here. Now on the outside I get a 1c, on the inside I get a 12c. That combines to be a 13c. All right, that's not what I wanted. I wanted a 7c. Now I can toss out the 6 and the 1. Try the 2 and the 3. Just put them in a spot and see if it works. If it doesn't, switch it up. Again, outsides and insides is all you're worried about. Out here I get a 2c, and here I get a 6c. Those combine to be an 8c. Still not right. Switch them up. Now be very careful and systematic. If I switch these and these, then I'm just going to kick back to what I've already got. So only switch either the front slots or the back slots, but don't switch both slots, because that just makes you back to what you already had. So I'm going to switch this to the 3c, this to the 2c. Out here I get a 6c, I'm sorry, a 3c. Inside I get a 4c. 3c and 4c sure enough combines to be the 7c that I needed. So this is the correct factored form. Now, that wasn't too bad for guess and check, but imagine if this 6 was a whole lot bigger. Let's say that it was a 20. 20 could split up as a 20 and a 1, a 2 and a 10, a 4 and a 5. Let's say this was a 48 that could split up as a 48 and a 1, a 24 and a 2, a 6 and an 8. So many combinations that you could do. Imagine all the guesswork that could be done. This is why your factoring by grouping, your box method, and your slide divide and reduce are very handy. So let's take a look first at that factoring by grouping. This was the old guess and check. I'll write that up here. What factoring by grouping does is, like I said, it tries to create that common binomial. So it takes the 6c squared plus 7c plus 2. And the first thing that you have to do is you have to take that 6 and multiply it to the 2. So I'm going to copy this down again, just so I've got something a little bit easier to work with. Take the 6 times 2, and that gives me a 12. What that tells me is I want two numbers that are going to multiply to be a 12, and they are going to add to be a, let's see, change that up, sorry. Multiply to be a 12, and they are going to add to be a 7. The reason I know that they're going to add to be a 7 and not subtract is because here, at the very least, I know that in the end, when I get that double parentheses, I know that this tells me my signs are going to be the same. This tells me they're both pluses, which tells me that when I FOIL it, outside and inside, those are going to combine by addition because the signs are the same. So these two numbers here are going to multiply to be 12. They're going to add to be a 7. That is going to be a 4 and a 3. So what happens with factoring by grouping is I'm going to take this up and I'm going to split it up as a 4C and a 3C. Because 4 and 3 adds to be 7, 4 times 3 will give me 12. Basically what I'm doing is I'm taking this trinomial that is sitting in front of me and I'm expanding it a bit. Here's the 6C squared, here's the 2, the 7C has now become a 4C and a 3C because 4C plus 3C will give me a 7C. Now what I'm going to do is I'm going to factor this as a 4 polynomial, which we looked at back in section 6.1. And I'm going to combine these two together as a pair, and I'm going to combine these two together as a pair. And when I combine these two, I look at them and I say, what's common to each one of those that I can divide out? Both of these are divisible by 2 and by a C. And then I'm going to write down in the parentheses what's left when I do the division. When I take this and divide it by 2C, I get a 3C. When I divide this by 2C, I get a 2. Now back here, there's nothing common that I can divide out. I'm just left with that 3C plus 2. But notice this looks a whole lot like that common binomial factoring, where within it, I've got a very odd looking term right here, and another very odd looking term right here. Both of those boxes have a 3C plus 2 in common. So I'm going to pull that common 3C plus 2 out. I'm going to write down in a parentheses what's left. Divide that 3C plus 2 out of here, I'm left with a 2C. Divide that 3C plus 2 out of here, I'm left with a 1, because something divided by itself is just a 1. This is my factored form. And notice that what's circled in blue here is the very same thing that's circled in green up there. So that's how factoring by grouping works. Now, like I said, the box method works very similar to the factoring by grouping. It's just it takes it and it sets it up in a different format. Because what box method does is it starts with this trinomial that we have from the beginning, and it starts the very same way in the sense that you take the 6 and you multiply it by 2 to get that 12. And that still indicates I want two numbers that will multiply to be 12, and they're going to add to be a 7. Again, I know they're going to add to be a 7 because I know that in the end, when I get those pair of binomials, this tells me the signs are going to be the same. This tells me they're both going to be pluses. The fact that they're the same tells me I'm going to combine the outsides and insides by addition, so I want them to add up to be a 7. But how the box method handles those that situation is it creates a box. And where this 7C gets split up as a 6C squared plus a 4C plus a 3C plus 2, just like we did here in the factoring by grouping, it handles it a little bit differently. Let me move my box down here to give myself a little more room. It takes those 4 terms and puts them within the box. So the front term goes up in the upper corner. The back term goes in the lower right-hand corner. Typically, you put your bigger number up here in the upper right-hand corner, or bigger term, that is, in the upper right-hand corner of the box. And you put your smaller term in the lower left-hand corner of the box. Now what you do is you factor every row and every column of the box. So I'm going to look at this row here, and I'm going to say what's common to a 6C squared and a 3C. Well, that's going to be a 3C. I look at this column and I say what's common to a 4C and a 2. That's a 2. I look at this row and say what's common to a 6C squared and a 4C. That's going to be a 2C. And I look at this one and say what's common to a 3C and a 2. That's just a 1. Outside of the box is where your factors are going to be. So this becomes a 2C plus 1, and this becomes a 3C plus 2. And notice that what's circled in red is the same thing that's circled in blue, and it's the same thing that's circled in green. So we're all coming to the same spot. Now, the last method that I'm going to show you, and I've got several more examples of this, but within this one problem, I'm going to show you slide, divide, and reduce. And like I said, the nice thing about slide, divide, and reduce is that the words tell you what to do. So I'm going to start with my 6c squared plus 7c plus 2. What happens is, it kind of does start the same way that factoring by grouping, the same way that the box method starts out, in the sense that I'm going to take this 6 and multiply it to that back number of 2. That's exactly what happened here, right there, and that's exactly what happened here, right there. But when I multiply it, it's like I'm taking that coefficient and removing it, but I'm removing it by multiplication. So 6 times 2 will give me a 12. Now the cool thing about slide, divide, and reduce is this creates a trinomial that's very easy to factor because I have a coefficient of 1. So what happens at this point is I go, well, I can set up a double parentheses pretty easy here. This will tell me my signs are the same. This will tell me they're both pluses. This will split up as a C and a C. I want two numbers that will multiply to be a 12. They're going to add to be a 7 because the signs are the same. That's a 4 and a 3. So I did this slide. Well, my goodness gracious, I misspelled divide. I can't believe I did that. There we go. So I did the slide. But the problem is this 6 doesn't just disappear. So I've got to bring it back into the picture and reverse the way that I removed it. I removed it by multiplication, so I'm going to bring it back in by division. So I'm going to divide it back in here, but I'm going to divide it into the numbers. I'm going to divide it into this 4, and I'm going to divide it into this 3. So there's the divide. Here's the slide. There's the divide. But now remember, it's slide, divide, and reduce. Now technically, you can find videos that describe slide, divide, and reduce out on YouTube, but you're not going to find slide, divide, and reduce. What you will find is slide and divide, because that's actually what it's called. But this notion of reducing is so important, so insanely important, that I have tried to start just changing the name of the method and call it slide, divide, and reduce. Because at this point, I need to look at these fractions and I need to ask myself, will they simplify? Will they reduce? Certainly, a 4/6 will reduce to a 2/3, and certainly a 3/6 will reduce to a 1/2. So there's the reduce step. At this point, I look at this and I go, you know what? I never factor and have fractions in the results here in those slots. Never do. So how would I clear out that fraction? How would I clear out the denominator of 3? Well, certainly I would multiply everything by 3. So when I take this first parentheses and multiply it by 3, I get a 3c plus a 2. And in this one, to clear out the 2, I'm going to take everything and multiply it by 2. So I get a 2c plus 1. Notice that my answer here in black is the same thing as the answer that's in blue, and it's the same thing as the answer that's in red. And the same thing as the answer that was in guess and check. I just simply erased it. But there's the 4 methods of guess and check, factoring by grouping that I erased, box method, slide, divide, and reduce. Notice that the other 3, other than guess and check, the other 3 all operate with the beginning notion of take that front coefficient, multiply it to the back, because that tells you the 2 numbers that you want to multiply to be the result of that product, and you want to either add or subtract them to create those middle terms. And like we said before, you have to be able to FOIL it in order to get back to the beginning. If you FOIL this out, 3c times 2c will give you a 6c squared. Outside here you get a 3c, and here you get a 4c. That gives you your 7c, and in the back 2 times 2 will certainly give you the 2 that's in the back. So let's try a couple more of these, because these are kind of some complicated methods here. Let's try a 3x squared plus 2x minus 8. So with the old guess and check, actually with any of these methods, you should always look first to see if there's something common that you can divide out before you do anything else. 3, 2, 8, nothing common that I can divide out. I can't take x's out of every single term, so I know that I'm just headed for a double parentheses. No common monomial factoring to be done from the beginning. So let's set up that, if we were to do guess and check, It's not too bad because there's only one way to split up the 3, but there's a couple of ways to split up the 8. So with guess and check, what I'm going to do is I'm going to say, well, this tells me my signs are going to be opposites. One's a plus, one's a minus. There is only one way to split up the 3x squared. So a 3x and an x. But the 8 could be an 8 and a 1, or it could be a 4 and a 2. So I just have to try something and see what happens. Try the 8 and the 1. Again, only outsides and insides is what you need to check. Out here I get a negative 3x. In here I get a positive 8x. Those combine to be a positive 5x. That's not right. Now remember, if it's right number, wrong sign, switch the signs. But if it's wrong number, switching the signs is not going to help because it will only turn this into a negative 5x. So I actually have to switch the numbers. Don't switch both the front slots and the back slots because that will just take you back to where you were. So I'll switch this to a 1, this to an 8. That gives me a negative 24 out here and a positive 1 out here. Well, that certainly doesn't give me a 2. That gives me a negative 23. And I know switching signs or switching the front slots will only kick me back to what I had. So that means throw out the 8 and the 1, try the 4 and the 2. Give it a shot, test it out. If it doesn't work, switch things up. Out here I get a negative 6x, in here I get a positive 4x. That gives me a negative 2x. Oh, close. Right number, wrong sign. Very easy to fix. Switch the signs out. That gives me a positive 6 here. Negative 4x here gives me a positive 2x. There we go. That's my answer for guess and check. Now, let's try out the factoring by grouping and the box method and slide, divide, and reduce. Because again, not too bad because there's only one way to split up that 3x. But what if that was bigger and we had so many combinations we needed to check? So let's give factoring by grouping a shot. So what factoring by grouping does is it says, let's start off and let's take this 3, the front coefficient, and let's multiply it to the 8. And that gives me a 24. So that tells me I want two numbers that will multiply to be 24. And because this sign is a minus, that tells me in the end I'm going to have opposite signs. Because of that, I know that I want numbers that will subtract to be this middle one of 2, not add to be the middle one of 2. So turning up two numbers that will multiply to be a 24 and subtract to be a 2, that's going to be a 6 and a 4. So what I'm going to do is I'm going to split this 2x up as a 6x and a minus 4x. So I have my 3x squared up front, 6x, and a minus 8 back here. So now, I'm sorry, that should be like this. There. Subtract for a 2. So now what I'm going to do is I'm going to group them up in pairs. So I have a pair right here and a pair right here. I'm going to divide out what's common to each of those pairs. This one I can divide a 3 and an x out. When I do, I'm left with an x plus a 2. Here I can divide a 4 out. And I'm left with a negative x and a negative 2. But notice that when I'm looking at this and I'm trying to group up this very odd looking term here and this very odd looking term here, I want the parentheses to be identical. Those parentheses are not identical. And if they're not identical, I cannot divide out the common binomial. So what if instead of dividing out a positive 4, I divided out a negative 4? If I did, then this would be a positive x and this would be a positive 2. Now those parentheses are identical. So I can divide out the common binomial that's in the parentheses, that x plus 2, and I can write down in a parentheses what's left when I do that division. Here I'm left with a 3x, here I'm left with a negative 4. And you can see that that is in fact the same thing that I got up here on the guess and check. A little bit of different order, the x plus 2 is first, the x plus 2 is in the back, but that's okay because multiplication is commutative. And remember, what I'm multiplying is parentheses times parentheses. That's what confuses people a lot of times, is figuring out when am I done. You are done when you have nothing but multiplication. Granted, I have an addition, I have a subtraction, but it is parentheses times parentheses. Oftentimes I'll put my hand over top of the parentheses, so I don't confuse myself about what's inside the parentheses. It is just this parentheses times that parentheses. So that's how I know that it's in factor form. And like I said, multiplication is commutative, so I can switch the parentheses around and it's okay. But that's what happens with factoring by grouping. So now let's take a look at that box method that, like I said, starts off the same way the factoring by grouping starts off. So here's my beginning, 3x squared plus 2x minus 8. And I'm going to start off by multiplying that 3 and that 8 to get a 24. And that tells me I want two numbers that will multiply for 24. And like I said before, they're going to subtract to be a 2, because in the end, this tells me I want different signs. That's still going to be a 6x and a 4x. So I'm still going to split this up as a 6x minus a 4x. But I'm going to handle those four terms a little bit different than I did with factoring by grouping. What I'm going to do instead is create a box. And in that box, I'm going to put my first term up top. I'm going to put my bigger term up here in the corner. And I'm going to put my smaller term down here in the corner. Notice that what I'm doing this time is I'm keeping the sign with it. That's a negative 4. It's the sign in front is the sign that goes, and a negative 8 out here. So now what I'm going to do is I'm going to factor along the rows and along the columns, and then whatever's on the outside will be my answer. So along this row, I can divide a 3 and an x out. Along this row, I can divide a negative 4 out. Along this row, it's common that an x is there, and along that column, and along this column, it's common that there's a 2 there. So that tells me that on the outside here, I've got a factor of 3x minus 4, and across this top, I've got a factor of an x plus 2. And again, that's the very same thing that I got from Guess and Check from our factoring by grouping. So now let's take a look, lastly, at that slide, divide, and reduce. So with slide, divide, and reduce, we start off with our trinomial that we began with. And the first step is to slide that out by multiplication. Here's the slide. When we slide it out by multiplication, we're left with an x squared plus a 2x minus 24. That creates a trinomial that's very easy to factor. So when we go to factor it, double parentheses, and once again, this tells me my signs are going to be different. Front slots come from here, so it's an x and an x. Two numbers that will multiply to be a 24, subtract to be a 2. That's the same thing that we did here. That's the same thing we did here. Those two numbers are still a 6 and a 4. But now what happens is, with slide, divide, and reduce, I need to divide the 3 out, or the 3 that I multiplied out, I need to divide it back in. So here comes the division part. That I'm going to take it, I'm going to divide it into the 6, and I'm going to divide it into the 4. There's your divide. But remember, the reducing part is incredibly important. So what I'm going to do now is I'm going to reduce those fractions. 6 divided by 3 does reduce to a 2, and 4 over 3 does not reduce. And then the last step is simply to say, I don't have fractions in my answers whenever I factor, so I'm going to clear out that denominator of 3. I'm going to multiply everything in there by 3, so I get a 3x minus a 4. And here, I don't need to worry about it. It's in great form. And that's the same thing in both cases. I do want to point out how important it is to do the reducing part, because notice here that if I did not reduce this 6 over 3, then what would happen is I would clear out that fraction as well, and I would end up with a 3x plus 6, and I would end up with a 3x minus 4. Clearly what's written in red is not the same thing as written in green here. The 3x minus 4s are the same, but this part's not the same. And you may say, well, that's okay, because you said I could take a look at this and I can divide out what's common. A 3 is common. Well, sure, I can divide that common 3 out and be left with an x plus 2. But see, the problem is, even though this much of it looks the same as this answer, I have this 3 out front. And if I multiply all this out, I need to get back to the beginning, which was my 3x squared plus 2x minus 8. And if I multiply all this out, I'm actually going to get back to a 6x squared plus a 4x minus 16. That's not the same thing. So this reducing step, like I said, is insanely important. You've got to be sure that you reduce so that you clear things out properly as they should be. All right, one more, just to get ourselves really good at this. Once again, you always need to look first to see is there something common that you can divide out before you do anything else, and there isn't. So with my old guess and check, I'm going to set up my double parentheses. This tells me my signs are the same. This tells me they're both minuses. The nice thing here is that 5p squared only splits up as a 5p and a p. However, the 8 splits up in multiple ways, 8 and a 1, 4 and a 2. Of course, it's really only 2 ways. Just try stuff and see if it works. Put the 8 here, the 1 here. Outside, I get a negative 5p. Inside, I get a negative 8p. That's a negative 13p. That doesn't work. But before I toss it out, switch things up. Call this the 1, call this the 8. Outside, I get a negative 40p. Inside a negative 1p. Whoa, that's a negative 41p. That's certainly not right. Now it is time to toss out the 8 and the 1. So give the 4 and the 2 a shot. Outside, I get a negative 10p. Inside, a negative 4p. Those combine to be a negative 14p. Still not right. Switch it up. And remember, only switch one set of slots. Don't switch both slots. So I get a minus 20p and a negative 2p. There we go. There's the negative 22p. Like I said before, that's not really that bad. It didn't take too long, but certainly could be bigger. So let's take a look at factoring by grouping. And what happens with factoring by grouping, like we said before, is we are first going to multiply that 5 times the 8 to get 40. That tells me I want two numbers that will multiply for 40. And because these signs will be the same, as you saw right here, those two are going to add up to be the 22 in the middle. That's going to be a 20 and a 2. So this will split up as a negative 20p and a negative 2p, because these two need to combine to be that middle term. That's why they're both going to be negative. Now I'm going to take that 4 polynomial and I'm going to split up I'm going to group up the first two and group up the back two. Within the first two, I can divide a 5 and a p out. I'll be left with a p minus 4. And here, remember, if I only divide out the 2, then I'll be left with a negative p, and those parentheses will not be identical. So I need to divide the negative 2 out so that I'll get a p minus 4, and now those parentheses can be identical. Because now I've created two, okay, very odd looking terms, yes, but within each of those, they both have that p minus 4 in common. So I'm going to divide the p minus 4 out. I'll be left with a 5p here. I'll be left with a 2 here. And notice, like we said before, same thing in green as what's in blue. So, test out that box method. And so we start off the same. Here is the trinomial that we began with. And so I'm going to multiply 5 times 8 to get 40. So I want two numbers that will multiply for 40. And they're going to add up for a 22. And once again, that's going to be my negative 20p and my negative 2p. But just like I said before, we're going to handle it a little bit differently, putting it in a box. So here's my box. And my 5p squared will go in the upper left-hand corner. The 8 will go in the bottom corner. Bigger term up in the right, negative 20p. And smaller term down on the left, negative 2p. I failed to mention every time here, it helps a lot if you will take that bigger term and put it first when you're doing factoring by grouping. Put the bigger term first. Okay, so back to that box method. Now I'm going to factor along every row and factor along every column. Along this column, I can divide a p out. Along this column, I can divide out a 4. Along this column, I can divide out a 5p. And along this column, I can divide out a 2. Now, it gets to be a little bit confusing because it looks like it's going to be a p plus 4 and a 5p plus 2. But remember, this here tells me the signs are the same. This tells me they're both minuses, that within these double parentheses, I want these to be minuses. So that tells me I'm not going to pull a minus out of here on the front term, and I'm not going to pull a minus out here on the front term. So I need to divide a -4 out of each of these and a -2 out of each of these. And so that's how I get my factors within these two parentheses. And again, it's the same thing that you see in each of the other two methods. So now let's wrap it up with my slide, divide, and reduce. And the name tells you what to do. So we start off here with our trinomial of 5p minus 22p plus an 8. I'm going to slide it out by multiplication. There's the slide. That creates a p squared minus a 22p plus a 40. And that creates something that's fairly easy to factor because I have a leading coefficient of 1 here. So I'm going to split up my double parentheses, same signs, both minuses, front terms are going to be p's. Two numbers that will multiply for 40, they're going to add up for the -22 because these signs are the same. That's a 20 and a 2. Now, I multiplied the 5 out, I got to bring it back in by division. I only divide it into numbers, you never divide it into these letters. There's the divide. And like I mentioned before, that reducing is so important because if I do not reduce here, I'm going to end up multiplying through by 5, creating a much bigger factor than what I should have. So 20 divided by 5 is 4. And then as I look at this, I go, I never have fractions in my answer. So I'm going to clear out that fraction of 5, multiplying everything through by 5. And you can see I've got the same thing all the way through. So there's your 4 methods for your factoring by grouping, your box method, and your slide, divide, and reduce, and your guess and check. Let's take one last one before I shut it off, because this one's a pretty big one, and it shows, because a lot of people think, well, guess and check's not too bad, and it's not. I'm a big fan of guess and check, and a lot of people think it's not too bad. Let me make that an X. Because the numbers split up pretty evenly. They were small at first. But what happens when the numbers get a little bit bigger? Like for instance, this splits up as a 5 and a 3. It also splits up as a 15 and a 1. This splits up as a 4 and a 1, a 2 and a 2. The guesswork could get pretty large for that one. It could be a little tedious, could take a while. So this is where your factoring by grouping, your box method, your slide, divide, and reduce become very handy. Also want to point out here that I do have different variables in this, extra variables, and we're going to find out that having the extra variables really doesn't make a difference at all. So let's go ahead and take a look at that factoring by grouping. And remember, with factoring by grouping, the first thing that you do is you take that front coefficient and you multiply it to the back. And so that tells me that 15 times 4 is going to create 60. And that means that I want two numbers that will multiply for 60. Notice here this tells me sign same, both minuses. That tells me that in the end, with these two double parentheses, I'm going to have both minuses. When I check the outsides and insides, they're going to combine by addition. So I want the two numbers to add up to be that 16 right there. That's going to be a 6 and a 10. So this will split up as a -10xy and a -6xy. And I'm going to retain this part. So remember, what happens now is I combine up these front two terms and I combine up these back two terms. With the front two terms, I've got a 5 and an x common to each. When I divide it out, I'm left with an x minus 2y. Here, I can divide a 2y out. And remember, if I only divide a 2y out, I'm left with a -3x. Divide 15 by 5, I get a 3x. My apologies. When I factor a 2 out of here, I'm left with a -3x, but I want a positive 3x. So I'm going to divide a -2y out, leaving me with 3x. And when I take a -2y out of here and divide it out, I get a -2y. So I can see now that within each of these two very weird looking terms, I do have the same binomial in each of them. So I'm going to pull out that common binomial of 3x minus 2y, and then within this parentheses, I'm going to write down what's left, a 5x minus a 2y. And if you check it by FOIL, 3x times 5x is a 15x squared. Out here I get a negative 6xy, and here I get a negative 10xy like you see right there, which combines to be the negative 16xy. And a negative 2y times a negative 2y is a positive 4y squared. So that's how you do factoring by grouping, and you can see that having the extra variables in there really doesn't change anything at all. So what happens with the box method? Well, with the box method, we start off the same way. So I'm going to multiply the 15 times the 4 to get that 60. And that tells me I want two numbers that will multiply for 60. Those two numbers are going to add for the 16 because the signs are the same. So just like before, here's my 15x squared. This splits up as a negative 10xy and a negative 6xy, just like before with the factor by grouping method. But now I handle those terms differently, and I put them inside of that box. So here's the box. And I'm going to put my 15x squared up in the upper left-hand corner. My 4y squared will go in the bottom right-hand corner. Bigger term up here. Notice that I did that here as well. Bigger term was out front. And my smaller term is going to be in the lower left-hand corner. Now I'm going to factor across each row, factor up each column. Along this column, I can divide out a 3x. And along this column, I can divide out a 2y. Along this row, I can divide out a 5x, and along this column, I can divide out a 2y. But remember that within these parentheses, I do want to have minuses here. So that tells me I want to drag a negative 2y to here and a negative 2y to here. So that I get a 5x minus 2y along this one, and a 3x minus 2y along this one, giving me the very same thing that I got over here. And finally, slide, divide, and reduce. And the name tells you what to do. So I start off with my 15x squared minus 16xy plus 4y squared. And so first off, I'm going to slide it out by multiplication. That's the way all these methods have started. Let's multiply the front coefficient to the back. But now this creates something that's pretty easy to factor. So I'm going to set up my double parentheses. Split it up as an x and an x. Same signs, both minus. Split up my 60, two numbers that will multiply for 60 and add up to be a 16. There's my 10y and my 6y. But now I'm going to divide because that 15 doesn't just disappear, so I'm going to divide it in. And again, only divide it into the numbers. There's the divide. And that all-important step of reducing. So now I'm going to reduce my fractions. 10 over 15 reduces to a 2/3. And 6 over 15 reduces to a 2/5. And I look at this and I say, I never have fractions in there. How do I clear them out? Multiply everything in here by 3. And multiply everything in here by 5. And you can see I got the very same thing as I did in the other two. So there is your slide, divide, and reduce. So this is how you can factor your trinomials whenever you do not have a leading coefficient of 1. You also always need to look and make sure that you have divided out what's common to each and every term before you do anything else. But I'm going to put that in another video. So this will be the end of this one, and you can look for another video where we take this a little bit step further, add the common monomial factoring, and then go with each of these 4 methods. So look for that video next.